Hi Terry, how are you?
Hi there, how you doing? Give it a few minutes to let everybody join.
Yes, just reading our agenda.
Hello.
Hello there.
Hello.
Hey, how's everyone?
Yeah,
Good,
good,
how are
thanks.
you?
And you?
Good. Bit of a I haven't really done anything since we last talked in this area. I've been too busy with a mixture of work and life and so on. So I had some drama with some damage to the house and sorting out insurance claims, but it's pretty much sorted out now. So I don't really have much to add, but I did put some notes in the agenda. Um,
It's been
what
pretty
about you two?
apocalyptic for you guys, hasn't it?
It has been, yeah, but that's kind of in step with the world, really, when you think about it. Like it's not, you know, yeah. But I mean, having said that, we're doing very well with the coronavirus situation here. It's pretty much everything's more or less business as usual, other than travel. They're opening up. It's the end of next week, like football games and stuff like that. Um, Schools have been back for weeks now. No real change. Um, and the cafes and pubs are mostly open, and there's been no change. So I guess maybe we had such a bad start to the year, so maybe that's all right. So,
It's quite nice. London is opening up, but I think they have the situation, the virus, the infection rate less under control than Australia. It's worrisome.
yeah, and of course New Zealand is doing amazingly.
Yeah, except I noticed that they had the one case that was imported from the UK. I was like, great.
Yeah, and they were given special exceptions to travel
Yeah.
and stuff. So it's yeah, but what can you do? Um, so I'm just gonna. So we might as well kick things off, I guess. So as I was mentioning earlier, I haven't had much time to work on anything in the meantime. I'm trying to paste the attendees in the doc because of various dramas and work. But I did notice there was some changes flying by on the pull request.
Yeah, so I've made some further updates to the technology requirements table, which we can have a look at in a sec if you like. We've got that one outstanding pull request that you added a couple of weeks
Yes.
back. Have
And
you?
no, I haven't had a chance to look at that. But if I remember, the problem with that was it was a bit prescriptive. Like it was, or it wasn't so much of a requirement statement as a solution. Is
Yeah,
what I remember.
so if we think about shifting the solution aspects into the final chapter and then just specifying that piece as a set of requirements, and then
Mm-hmm.
we can just merge that one.
Yeah. So following up from last week, the only thing I had before we get to that was NB convert. So NB convert, I can't remember if it was you or David that brought it up, but is that something that's worthwhile mentioning? Is if there's a section in the doc on like supporting solution or an important solution? I think it's important if it's useful because the reality is notebooks are everywhere. So it's worthwhile highlighting, hey, there's this tool in use, you know, by the Netflixes and that of the world that can act as a bridge from, you know, from the notebook world to extracting the source code into regular source code. Do you think it's worthwhile, or is it too niche for that?
Well, what we need to be focusing on is really identifying what the challenges and the requirements are for the sort of medium to long term solution. So, you know, the role of the roadmap really is to communicate the big picture about what the challenges are and what capabilities we need to deliver on those challenges. If there are sort of short-term workarounds, then that's not necessarily the scope of the.
Right, so it's too, yeah, that's fair enough. I'd agree with that.
You know, I mean, if there's a specific solution, you know, technology solution that we want to discuss, then we can do that in the last chapter and and spell out how that might be used to meet a particular requirement at a particular point in time. But generally, these sorts of documents are more about that this is what the end goal needs to look like at a particular point in time, and this is how far we are along towards meeting that end goal at the moment. You know, with the idea that, you know, the document is there to encourage people to contribute solutions to known problems, and also to give everyone a feel for the maturity of the state of the art in a given field.
Yeah, it's not necessarily a good thing that it has to exist, but it seems something that's used. But yeah, no, that's fair enough. It was just brought up, and Raoul, who isn't here, was asking about things like that, and I remembered David or you said that that's the tool. So I guess some other interesting things, like since we talked last, all the big clouds said they stopped selling facial recognition to police forces and other agencies until, well, some of them have said it indefinitely, and others have said till they can, you know, be very confident in the bias of it, given how it's being used. So I thought that was a topical sort of thing, given that we often talk about the ethics of machine learning and its applications. That's like a red hot topic. IBM was the first one to announce that they wouldn't do it, but everyone kind of said, well, we don't use a lot of IBM stuff. It was Amazon and Microsoft that kind of have the bigger solution. I think the Amazon's face recognition is quite heavily used. I know it's in use here for various policing things. Like we even have, sounds absurd, but you know, cameras that look for people using mobile phones in their car. So, which is done with Amazon image recognition platform. It's not looking at faces though, so it's less of an issue. But there was I had a thought experiment when I was out and about today about explainability. People keep asking me about that, and then so I had this thought of experiment. If I showed people a book with and I covered up the title and said, "What are all these?" and they're all pictures of birds, and they say, "Yes, they're all birds," and I go, "How can you explain to me? Show me your working. How you know that they're birds?" And you can't. Like it's. So that to me, that was kind of, and I know you've sort of got this a bit clear in your mind, Terry, the explainability thing comes up a lot, but it's not, people might naively think, you know, you could go to some model and go, show me some grand graph or something, or some graphic or some trace of how you came to this decision. It's like, no, it doesn't really work that way. It's not like an explain plan for an Oracle query or something like that. It's it's more subtle, and it becomes more back to governance and what was it trained on, and did you have the right, you know, unit tests or whatever in place to make sure that it wasn't biased against facial features and so on. So I thought that was an interesting thought bubble. But, Jesse, sorry, Joe.
I see in other news that some enterprising entrepreneurs have found a way to extend Kubeflow so that they can use other people's Kubeflow instances to mine Bitcoin.
Well, I mean, the same. I'll just take note of that. That's funny. The same's happened with open Kubernetes consoles. Like the first I heard that Tesla were using Kubernetes was that their open Kubernetes admin console was hacked and used to run Bitcoin. And the same conclusion I always come to is like, well, at least it's that and not something more nefarious. Like it's as bad as it could be. Yeah, so, but maybe we just don't hear about the really bad stuff. It's like, you can say, well, it was hacked, but it was only running Bitcoin and everyone believes you, so yeah. Did Kara or Jesse had anything interesting you come across since the last time we chatted?
I'm afraid
No,
I've been equally
not like,
spammed.
so go on, Jesse.
You go.
No, I wanted to ask, this is actually a question. It's following from what you were saying, Terry, about your thought experiment with the birds. So how, as I understand this, the models are, depending on your, I guess, what model you're using, but in general, it's pattern matching. And when we ask for explainability, part of that is like, well, what patterns are being used? And it's hard to determine that until you see a flaw, like you realize the wrong pattern's being used. Do we have any thoughts on how that would be checked earlier in the process? Or like, what are we thinking about how that could be caught?
The challenge in a lot of cases is that we don't actually know what the patterns are that are being detected within the solution. So the system actually learns all of the patterns in a sort of hierarchical structure to be able to identify a particular object that has been learned. But we don't have direct perception over what the features are that it's detecting and how those break down into individual patterns. Now we can look at the neural network and see what the weights are within the network, but that doesn't necessarily translate easily into any meaningful understanding of what that is as part of an image. Specifically, if you were to crack someone's skull open and start poring through the neural connections, you'd be able to see certain things firing in response to certain images, but it still wouldn't tell you very much about what the perception was at that stage for that individual. So this is the underlying challenge, is that when you have a learning system rather than a coded system, it will learn to find a set of patterns that it can consistently recognize as something, but it's very hard for you to have an understanding of what those patterns actually are and break them out with distinct separate meanings.
Yeah, because sometimes, sorry, Jesse.
No, you go. I'll hold my thought.
I was just I was scrolling back through the notes, and there was a link to one of the earlier sessions where there was a AI-based medical algorithm that favored white people for healthcare programs, and there was nothing to do with race, or the effects were quite subtle. There was no one feature that you could pull out and go, well, this is tied to this. It was like a multi-dimensional problem that's hard to explain, but essentially it was just capturing the systemic, bias that was already in the system. So it's just echoing the unfortunate state of the real world. So I guess I don't know how any technical explainability would have helped in that case ahead of time. it's like, yeah, sorry, you go, Jesse.
Yeah, so that leads into a similar thought that I'm having, which is how do we define the wrong pattern? And especially with these learning systems, it seems like you kind of have to get it wrong before you know it can be wrong. Yeah, so I think the context of where the algorithm is deployed, and then you see, okay, this is not what we expected in this context, but that's a very, very subtle problem in itself. Yeah, so
and maybe
I
it's
think,
like maybe it's like airline. You know, we're in the stage of early 60s, 50s jet airliner stuff where they crashed, and every crash would yield a black box that would categorically make that problem not happen again. And then, over time we evolve these safeguards. So maybe that's what we're missing is, stuff like the facial stuff that all the big clouds shut down in the last week or two since our last meeting. It happens that quickly. That should never happen again, because anytime, there's some sort of thing that anything to do with face is in there, then you've got to have a test suite in there, or you've got to have some, there's some compliance check that's right at the start to go, well, do you have some test data that tries out for that's basically the unit testing or integration testing, and we just accrete those specific cases. If it's medical, then do we have some test sets where we deliberately put in different racial profiles and make sure that the output isn't correlated? In cases of medical or geographic things, I don't know, maybe there's some set of knowledge that it's like, oh, you're working in this domain now. For you to legally deploy this model, you'll need to have showed that you've tested in these ways. And that's all I can think of right now.
Yeah, and I think there are two scenarios here really. Obviously, if you look at the human case, then you're talking about general intelligence, and so you can do iterative explainability by asking someone what something is, and then asking them how they know, and they'll probably give you a group of gross features, like, if it's a bird, well, it's got a beak and it's got wings, and then you have to drill into each of those things and then say, how do you know it's a beak? And then they'll say, well, it's got this curve to it, and it appears to be made of this hardness of material with this specular reflectivity. And then you're starting to drill down into a bunch of stuff, and then eventually you'll get to a bunch of graphic primitives like curves and lines. So you could, in theory, build that degree of introspection into a machine learning system in the future, given enough processing power. So you could have it query itself to establish how it's recognizing the model. But in the intermediate period, obviously the approaches that we have open to us are going to be, as you say, the retrospective black box testing against known data sets with an expectation of a particular statistical distribution on the results, and also upfront data analysis on the training data to make sure that we have a representative distribution of information in the original training data.
what about the potential use of a GAN?
What's again?
Where you have it like a generative adversarial network. So essentially you have two networks, one trying to trick the other. They use it in honing higher, for example, like higher quality reproductions of like you draw an outline of a boot, and then the network generates a picture of a real boot, and then you have a separate network which says, no, that's not a real boot, that's a generated boot. Because I've been trained on this this warehouse of real boots, but then each one gets updated. So essentially it's called an adversarial network, because one's trying to trick and the other one's trying to catch out. I'm wondering if there's some role there, if we could use that as to a degree, a quality assurance technique. But to be honest, I think the problem is actually a little bit more philosophical. I think this is, as Terry keeps pointing out, like we're really talking about learning systems rather than coded systems. And it's very tempting to think that we can detect with accuracy the mechanics of the end result because we have access to the network. Just as we have physical access to our own brains, it doesn't necessarily mean that we can deterministically explain why we reach the conclusions.
Yeah, like
it's more like probabilistic.
Yeah, the bird example. Like I'm sure I would say things like Terry said, but then I'd be wrong, and then someone would point out, but what about this thing? And I'm like, oh yeah, and I'm just kind of making it up. So it's like, I don't think we're very good at explaining maybe Terry is, but I'm not very good at explaining how you.
Yeah, for me, it feels just kind of like procedural versus probabilistic, like if you have a high probability of accuracy, that's probably the best really that we'll get from these systems. Like if you've got a 95% confidence rate in this algorithm picking birds, then you have some policy that your company is comfortable in deploying that in some production system.
So I guess this is something for there's the technical requirements of explainability and bias prevention, I guess, are two requirements. And then, there's some ideas for the solution section after that. Did you want to sort of dive into share the document now, Terry, with what bit we're up to?
Yeah, sure. So, in terms of recent updates, we're mostly in the technology.
Harry, would you like to share your screen?
Yeah, if you pin his video in the top, then you can see the screen. I'm seeing the screen instead of Terry's face.
Thank you. Got it.
Yeah.
So most recently, what I've added is these sections relating to privacy. There's some, let me just switch things around so I can see what I'm looking at. So we there are some specific requirements that we would like to see in solutions that relate to the management of data privacy, because this is looking like being one of the harder challenges going forward. If customers are operating in certain jurisdictions with quite strict data privacy requirements, there's already an expectation that customers are granting permission to use their data as part of model training exercises, and they thus have the right to withdraw that permission at any time, which then, of course, invalidates that model. So the expectation would be that we would have to support a scenario where we have to constantly track permissions to use data that has fed into the creation of models and then potentially invalidate and recreate those models. Now, at one level, that's just a data processing exercise. But at another level, it's actually an extreme challenge to an organization because it could be used as an economic attack vector. So if you can seed a model with a number of willing participants, and then have them individually withdraw their permissions over a period of time, you can force that company to have to regenerate its model over multiple iterations. And if that model costs you $1 million of compute time to actually create, then every single withdrawal could potentially run up $1 million bill.
Is that something that happened? Not this economic attack, which is novel, but I mean, is that sort of in some extreme cases, the cost of training? Like a model could cost, 6 to 7 figures.
Yeah,
of compute training.
I mean, if a sort of medium-sized model, you're probably looking about $25,000 worth of compute time to run up a medium-sized model. But for a large model, you're potentially talking in millions.
Can you talk more about that 25? So not the specific 25, but like what sort of model is that? Is that is there an example of that? I mean, just because I'm not familiar with things that big. The stuff I'm used to doing is measured in dozens of dollars per hour. I don't know of anything myself at that scale, but what are some examples, if you know and can share, of things at that scale, like the medium scale? Because that's even the medium scale, that's horrific.
If you're looking at say the systems that Uber is using for managing driver allocation to requests, the last time I spoke with them, they were using around 700 servers to run that particular application.
For how long does it take to train that model?
Well, again, you're typically looking at people trying to optimize their training so that they will execute in less than a week. So the way the maths tends to work out at the moment is that you have to make a trade-off between the amount of resources you can afford to get your hands on to train across, the amenability of your problem to being broken into parallel chunks, and how long you're willing to wait for a result. So typically longer than a week becomes unsustainable because people start to forget what it was that they were optimizing for.
And that's kind of I wouldn't say it's a sweet spot, but that's kind of what people have converged to, is it's right. And is it so with models like that, is it reasonable to expect that most of them would have some tempo of retraining? Like obviously not every week. In that case, maybe not even every month, but every 3 months. Is that could you sort of put a finger in there and say, well, in reality, everyone's going to be retraining every 3 months? What I'm getting at is that could there be words put into the effect that, it's, or is it reasonable that if consent to use information for a training set is revoked, then it can just be removed from the next cycle if it is a cyclical thing? Because then there's, or is it, yeah.
That's going to be the interesting legal challenge, because there's nothing defined at the moment. So I don't think GDPR says anything about how quickly you have to respond to the request.
you know, that would be an effective solution if that was the case. If it's like, if you said, look, our model is retrained on some tempo, then all you have to show is that you are removing the data when it's requested, so that when the training run does run, it won't be taken into consideration, but you don't have to drop everything.
You also have competing challenges, which is that in many cases, the assumption is that you're creating a model that is immutable because it represents a particular known and tested state at a moment in time, which is itself somehow enshrined in legal compliance. So you've then got the challenge that becomes a benchmark by which you're measuring something else, and it shouldn't change. So this is definitely going to be one of the areas where we find irreconcilable conflicts in government policy that creates the scenarios where you can't actually square the circle.
I'm just taking some notes.
So this is interesting because twice already we've come up against this wall of like, well, how this will be handled is eventually through legal, like government policy, and that will vary from government to government. And I'm wondering, like, okay, are we just flagging like these are issues that will come up and will have to be handled by society in a legal way, or how is this relating to our roadmap?
So what you'll find is that nearly the entirety of practical work in AI is about flagging the ways in which it completely breaks modern society, because society is just a set of heuristics that were built on the assumption that only humans could think and make decisions. And so, you know, there are many classic examples of how all of our existing legal and governance structures break down as soon as you let a machine make a decision. So, for example, autonomous vehicles create a massive upset for the insurance industry, because insurance is basically a protection against individual liability because somebody caused an accident. But if the accident was caused by an autonomous vehicle, then there's no human to blame, so nobody to sue. So then you have to create the argument of, well, then is the manufacturer of the AI liable, in which case are they liable for all accidents, in which case is autonomous transport actually commercially viable because you just get sued off the face of the planet, or do you have to create an entire new set of insurance products to ensure the company, the manufacturer, rather than the owner of the vehicle? Or do you create legal fictions as workarounds? For example, do you draw on some of the chattel slavery legislation to define artificial intelligence systems as slaves, and then use legal precedent to treat them under that existing framework, which then obviously creates a whole bunch of other ethical issues surrounding that. So the whole space is a massive minefield of very difficult challenges that relate to the way in which we've optimized our governance systems over the course of our human history, and how we now have to update all of those because they're no longer correct assumptions.
I mean, the fact that this stuff is flagged which I think it was the words Kara used, is interesting, because people might see this and go, it makes them think, but then they can think clearly, okay, do I really want to do this? Is this worth the cost? Is the benefit worth all the hassle? Or I am now very clear that I'm not, you know, the way I'm applying this technology is not in any way, you know, it's just an extra analysis tool or something, or it's just an extra module of software that's not being used in some, you know, human decisioning way. And the fact that you've been mindful about it is helpful alone, because there's a bunch of, I'd say most, you know, day-to-day applications probably won't run into this. Maybe not the stuff that Terry spends his time thinking about, but sort of the run-of-the-mill stuff that a lot of developers, I think, will use machine learning for. Probably won't, you know, it won't have anything more to do with legal problems than using, you know, Node.js versus Rails or something.
I think that is an interesting one, because I'm actually seeing lots of scenarios where it is almost immediately a problem, because it already falls foul of existing legislation, because there's been quite a lot of knee-jerk legislation put in place already, especially in Europe. So, you know, for example, there's very broad sweeping concerns around automated decision-making systems relating to you know, things like loans and stuff like that. And whilst the concern
but if
was
then,
in one particular area, the legislation was written to apply to any example of an automated system making a decision, requiring that it should have explainability. So even though you might be working on a relatively trivial machine learning solution as part of a larger application, the fact that you're using a machine learning algorithm to make a decision relating to some part of something that impacts a human being means that you fall foul of this legislation and are required to have, you know, auditability and you know, explainability. So when it comes to the demands on future MLOps teams, a lot of these things will be the bread and butter of what they're being forced to do on a daily basis, and so making sure that we're shaping the tools to understand that requirement is quite important at this stage.
yeah, I guess if it's not, like, say if it's a recommendations system, like that old cliche of Amazon or Netflix, or some of the other Kaggle data sets around, you know, house prices and things like that, they're not making decisions. They seem lower risk. I guess where they become risky is if those recommendations become decisions or input to something that makes a decision, like the house price Kaggle example. Well, there's lots of them. There's lots of exercises to do with that. There's lots of data sets you can use. You could estimate for a given area what a house is worth or maybe worth. If that was just, you know, for a real estate website, that's fine. But if you're using that as a feature that goes into something else that might use machine learning itself, or might just be plain old, you know, if then code, then it could get into legal hot water if you're using that to make effectively a decision. It's like, this person can't afford that, or we won't prove it because we don't think it's worth that. And then, yeah, so I guess it's never that clear cut. Just I'm trying to work out why it is for machine learning models versus handwritten code, and I guess it's the richness of the predictions that they can make. You wouldn't write code by hand that would estimate house values, and it just would be it would just be an annoying thing to do. You just wouldn't do it, so you don't tend to implement those features by hand.
Well, in many cases, it actually comes down to the fact that AI systems can't vote.
Right.
So what you will find is that people are in many cases lobbying against AI solutions to things because they fear job losses, and politicians are then finding themselves in a situation where all of their voters are predominantly opposed to the technology, and there's no advantage to them to voting in favor of the technology because the technology can't vote back. So you tend to get quite a strong skew against the technology. So it's quite easy for people to lobby for very interventionist regulation, and we've certainly seen that very rapidly in the EU, with a lot of very strict regulation being proposed, which hasn't been counteracted by any strong opposing lobby defending the advantages of having those systems. But it's likely that what will happen is that you'll see a gradual economic drift over time, as the jurisdictions which are most favorable to machine learning solutions gain more and more commercial advantages over those that don't permit them, and gradually pull further ahead economically.
Can I ask a question? How are we thinking about the audience of the MLOps roadmap? I was previously assuming that it would be mostly technical. So I'm kind of thinking of my own developers, and they're trying to understand, hey, what are the options for DevOps in general? So they come in and there's some exciting new technology, and they're wanting to see some guidance around here. But is our audience actually broader? And is the legal discussion relevant because of that, or should we be thinking about actually creating kind of two categories of audiences? I think that the legal discussion is certainly relevant. I'm just, yeah, for myself, it's a genuine question. I'm confused exactly who our audience is that we're writing to. Yeah.
So the fundamental challenge is that the majority of the consumers of MLOps will be data science focused rather than technical in the sense that you probably think about it. So they'll be highly skilled in particular areas of mathematics and analytical approaches, but may only be moderately skilled coders, typically in a single language and focused in a particularly narrow domain space. So they're the customer base for these solutions, and they're the people who are developing the state of the art in terms of the machine learning solutions themselves. But they also typically lack any experience of building technology products and managing them in production environments. So statistically, at the moment, over 80% of machine learning ideas fail to make it commercially because the teams are lacking the breadth of experience to be able to actually build a product rather than just a model. So the big gap right now is that we need tooling that reflects, the past 70 years of software development experience, and provides all of the coverage of all of the various problems associated with managing technology assets and ownership of technology. And we need to take that knowledge base and apply it to the machine learning domain, so that those people who are focused on machine learning have another tool that they can use, where they don't, in most cases, need to know most of that information. It just happens by magic because of the MLOps tooling that they're applying. But then the challenge is that in order to build that tooling, you're going to need armies of software developers, because the tooling will have to be designed and built in a traditional manner. So that means that you have to have a bunch of developers who understand the true problem space from the data science perspective, so they know which problems they have to be able to solve. So the challenge is right now that that's not happening as part of a natural process. So what's been happening is that the data scientists have been reinventing the wheel, learning from first principles how to manage software assets, and the programmers are sitting there watching in horror, but not able to really help. So the purpose of the roadmap really is to bridge that divide and cross the streams, if you like, so that the two sets of knowledge bases can be merged, and we can accelerate the overall effort in getting us to the end goal and being able to build reliable machine learning.
Well, thank you for detailing that. Are the legal problems really the problem of the developer or the data scientists? Like should that be a problem they're solving? From my perspective, it's much more of kind of a one level up. It's more of a business problem. There should be somebody that's responsible at the head of the project in terms of legal compliance in whatever country that company is operating in.
So the challenge is that when you're dealing with intrinsically decision-making systems, unlike software systems where you'll occasionally have one that has a legal compliance requirement, the expectation is that in most cases there will be some level of legal compliance requirement, and that will just get worse and worse over time as more and more new legal precedent gets set and more governments start to legislate for different scenarios in different industries. So the expectation is that a large part of asset management for machine learning is going to involve regulatory compliance, and the more of that we can automate as part of our processes, the more cost effective it's going to be to actually operate in that space. So you have to think about it in terms of total cost of ownership for technology, and the cost of ownership for a machine learning model is going to be intrinsically higher than a normal software asset of a similar complexity, simply because the standards to which it will be held will be at least an order of magnitude higher than the equivalent software.
And that sort of brings it to the CD foundation. The reason why this is part of it is because it's clear that pipelines and continuous delivery are completely what's related here, more so than even regular software. And even there, it's proven with studies of thousands of organizations, the Dora metrics and all that, to help a lot. So it's reasonable to believe that for this more complex domain, it should help even more. It's not just that the requirements on it are harder and the legal issues and all that other stuff, but even just the mechanics of, taking hours to do things or days to train things, and the cost of things, it sort of begs for that kind of solution. So I guess that's the background of why it's part of this. But I guess from Jesse's point of view, then it's probably more tilted to sort of specialist practitioners. I guess a subset of it would be interesting to developers, like I think of myself as sort of a developer that picks up machine learning and learns enough as I go. I'm not a data scientist. So a portion of it's relevant to me, but I need to be aware of some of the bigger ramifications because it's playing with fire. But yet, it's not going to be like a toolkit for me, the document anyway of how to do it. But I guess the user interface to me would be whether it's an implementation, encoded in Jenkins X or Quick Starts or some other opinionated thing. From a developer's point of view, that's what I care about, and then I know that it satisfies certain things and not others. So I guess it's not like a how-to. I guess that's.
And do you see that including legal regulation? Like, do you see a JX UI that says, "Oh, hang on, you're in danger of"?
I don't know. Terry might have thoughts on that. I'd be surprised, but yeah, I don't know.
Because I suppose that's where my confusion is. Yeah.
I mean, if you think about it already with our existing software pipelines, we do this. So, for example, Jenkins X now has the capability to do open source license scanning. So you can add a plugin into that, and every time you run a build, it will scan your dependencies and the dependencies of your dependencies, evaluate all of the licenses, and then warn you if you've got any licenses that change the compliance regime that you're operating within for your piece of software.
That's a really good point.
So somewhat yes, but it's not going to be. It's not going to be legal compliance in a box, sort of like it's you, or maybe Clippy pops up and says it looks like you're doing facial recognition. Would you like a lawyer? Would you like? Don't do that. It's like you're making a decision that's will affect whether people can send their kids to college or not.
It's like those plugins that catch you before you send an angry email. Like, take a breath.
Yeah.
Do you really want to deploy this?
Yeah, it's this whole area is definitely the Jurassic Park cliche of everyone's so busy to thinking whether they could. They didn't stop to think if they should. Like sometimes in this area, I mean, maybe that's one of the things about being professional. Like in other fields, professionals have an obligation to say no to things and not do certain things if it's wrong. Like there's nothing like that really in software, but you look at what happened with VW and faking the results of diesel pollution and things like that. That day is coming where it's like you'll be maybe personally legally responsible for things.
I just think about like my own company. Like I think it would be irresponsible for me to consider my developers to be a certain level of legal awareness, obviously, right? Like I don't want them to be like pirating software or, using obviously wrong licenses. But I just feel like there's like a chain of responsibility within companies when it comes to these things. And I'm just wondering, I mean, not to labor the point, but I'm just wondering how much are we trying to boil the ocean versus can we, like it really feels like the two primary audiences are the data scientists and the programmers. And while there is some overlap with legal concerns there, and there is certainly an opportunity to support, to put in some nice support for that at a technical level, for me, it feels a bit off center to be focusing a lot on the legals.
So
yeah,
again,
I don't know.
This is where there's a big difference between the software community and the data science community. So you'll find that embedded in a data science team, the ethical debate is a daily occurrence, and so that's a key upfront part of every project, because the implicitly when you're running a software team, you're assuming that your HR processes have selected for a group of people who have a certain moral code and who conform to the culture of your organization. And sometimes you end up building the wrong culture and you end up with a toxic outcome. But in general, that's a safe assumption that you're going to get people who will speak up against things that they see to be morally wrong, or worse, will just whistle blow on you so that somebody else intervenes. But when you're dealing with decision-making systems, at this point in time, they have no ability to have their own moral code. So they're not self-policing, and unless we artificially build a conscience around the systems that we're designing, they have the potential to act in surprisingly psychopathic ways because they lack any ability to introspect on the decisions that they're making, other than the ways in which they were trained.
Fascinating.
And in many cases, that's a complete blind spot to people working on the systems, because they're so used to working around other humans that it doesn't occur to them that the thing that they're building doesn't have a lot of the intrinsic capabilities that other humans do, and so using a theory of mind on them doesn't work, and they can therefore behave in ways that would seem extremely bad from a reputational damage perspective to third parties. So one of the big risks that you deal with deploying machine learning products are, is this thing going to unexpectedly kill someone, or start espousing racist views, or something equally as horrific and destroy our company as a result? And we have got prior examples of those scenarios as horrible warnings from history.
That I can understand, and I think I can see the bridge there. I mean, I look at that really kind of under the QA umbrella. Like, is this network behaving with the intention that we would hope it, that we intended it to? Yeah, I think, I mean, speaking from the programmer perspective, we kind of think of software architecture. So we're just like, is it scalable? Is it secure? Is it fault tolerant? We're kind of just thinking about, does the thing hold together under these external kind of mechanical stresses, I suppose. That's really kind of how, that's our main concern. And then it still feels like it's kind of a slightly different role. Like it feels like we're kind of overloading the developer if we were to get to have them have that concern as well. It feels much more like it's almost like a UX type thing. Like, what's the end product? Is the end product actually delivering the value that we hope, or is it actually delivering something very toxic and off point and damaging to, upsetting to our customers and damaging to our brand? It feels like a slightly different problem domain. So that's just my perspective.
It's really important here to recognize that there is no developer. So
I understand with
the sense, you have a controlling mind that is building the software and telling it what to do.
Yep.
But in machine learning, you've got someone who's building a structure to feed some training data into an algorithm, but then the development step is that algorithm training itself to pass a test. And so you have no control over how it trains itself and what it learns, other than the black box inputs that you can put in through the training structure and choices of machine learning techniques that you use. But the end result is no different from a child learning something. that it's entirely self-driven based on the experience that was fed into it. So as a result, you have a new set of non-functional requirements. So, you know, above and beyond it being scalable and resilient and reliable and all the rest of it, you also have to say, okay, well, is it racist? Is it psychopathic?
You know what we need? So we have these things like SOLID, for example, like these acronyms to help us think about these principles that we need to build, you know, large scale systems by. Potentially we need something like this here to make us kind of think through a set of principles around, you know, have we considered certain problems in this space?
Yeah, so there's a set of disciplines called responsible AI, which cover off most of these areas, and we do give reference to that in the early stages of the document, and we need to expand.
That's
on
right.
that
I remember that.
further.
Yeah.
So yeah, you'll find there's a whole new field of work in AI ethics and the machine responsibility, and in fact, there's been a recent conference focused exactly on that. So there are a lot of people working on this, and it's actually quite important that we start to draw the conclusions of that work into the MLOps process, so that it becomes a first-class citizen of, you know, the way that we build our machine learning solutions in the future. You know, it's insufficient to run these as pure business processes, because in many cases they need to act as automated gateways to you know, to prevent you from deploying something. Might also help us to head off a future Skynet situation.
Well, I think we might have to call it a day or a night, morning, whatever it is. We're on the hour now, so taken some notes. I'll probably add some more, and I've got some things to follow up in the document. But yeah, it was a good discussion. So, anything else? We sign off now.
All good for me.
Yeah,
Thank you.
Thanks everyone, and
Thanks.
As usual, if you've got anything, feel free to fire a PR across.
Great. Thanks. Talk to you next time.
Thanks, everyone.
Bye.
See you. Bye.